I'm Cheap Chicken. Today we're going to learn about 5.2, just the basics. I'm Miguel. Where you go?
Okay, so today is section 5.2. It's called Sum and Difference of Two Angles. It's about this little group of formulas. And I don't expect you to memorize it. And you might wonder, how did they even come up with these things? Well, it's like from 5.1. They're saying, is this the same as this? And they do a little proof. But what is this for? And also, here they are in the book. You'll find a little blue box of them. So the point of this is old school. And I know this was the homework, but you don't have to do it all. Just do the basics. You get the idea. The way they came up with this, they're kind of saying, well, if you take the first one, alpha and beta, this represents two angles. And it says, well, you could do this. The way they came up with this is, say I wanted to know the sine of 15 degrees. And so in the past, you didn't have a calculator. And you might look at your table and say, well, this is the only ones I know. I know sine of 30, I know 45 and 60. And you can't just go, some people think, well, that's half of that, so I'll just cut this answer in half. No, it's totally wrong. Because, well, would you double 30 and say, well, if I double that, that must be 60? No, doesn't work that way. Would you double 60 and say, well, 120 must be double that answer? No, it's the same answer. See, it doesn't work that way. But what you could do is say, the sine of 15 is, how about I change this to something on my list? And I can say, well, 15 is like 60 degrees minus 45 degrees. That's true. And then you'd match up to one of these rules. It says, okay, you take the sine of the first one, cosine of the second one, subtract cosine of the first one, that's alpha, sine of the second one. So in order to use sine of alpha, the first one, this would be alpha, this would be beta. So you'd say 60, and then you're supposed to times it by the cosine of 45 degrees, and then it says subtract cosine of the first one, 60 degrees, times sine of the second one, 45 degrees. And then I could look these up in my chart, or maybe I had them memorized. I could look each one of these up and kind of go, okay, sine of 60 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Cosine of 60 is 1/2. And 45 is radical 2 over 2. And then I could go, okay, 3 times 2, that's radical 6. And 2 times 2 is 4. 1 times radical 2 is 2, and 2 times 2 is 4. And we have a common denominator. So I could call this radical 6 minus radical 2 over 4. Okay, this is completely old school. It's kind of obsolete. After all, I could just use my Casio and get the answer right here. But check out this, my Casio. Sine of 15. It says radical 6. What? Why would it even give me a crazy answer? That's what it did. I should just hit the decimal button and get something we would be more expecting. So this is actually 0.2588. So this is really, really old school. It's really not that important anymore. That's the basics of this, why they did it. Sometimes they give you a problem backwards and say, hey, what did this used to be? And you could turn it into this. One thing that's cool though, here's a little problem. Number 33 in the homework, okay, says sine of an angle, they put x, I could put theta, plus pi over 2 is equal to cosine of x. Think about this. If you think about what this actually says, pi over 2 is like 90 degrees, isn't it? The angle plus 90 degrees is just like the cosine of the angle. Oops, I should use theta, because I use theta and theta. I could use x and x. Remember when we did this graph? The sine graph looks just like the cosine graph. It's just starting over 90 degrees. If I cut off part of the yellow graph and said, hey, that looks like the cosine graph. Or if I just started this guy here. So the sine graph is just the cosine graph, just bumped over 90 degrees. That's what this says. If you took added 90 degrees, it's just a cosine graph. But could you prove it? Well, yeah, I could graph it, but could you prove it? And you go, yeah, actually, I can. That looks like one of these rules. This is sine of something plus something. This is the one that says alpha plus beta. And then I could find it on my list. Sine, cosine, cosine, sine. So sine alpha cosine beta plus cosine alpha sine beta. And so what I'm going to do is I'm going to replace all the alphas with that and all the betas with that. So over here, I'm going to go sine of alpha, which is just theta. Okay, I don't know what it is. Cosine of pi over 2 plus cosine of alpha, the first one, sine of beta. Beta is the second one. Just alpha, beta, it's 1 and 2. Pi over 2. Now, wait, don't stop yet. Okay, I don't know sine of this, but cosine of pi over 2, I can look that up. Of course, I should have it memorized. Cosine of pi over 2, cosine is the x, pi over 2, way up here. The cosine is the x, 0, or I could just look on here. Cosine pi over 2 is 0. So this is 0. Cosine of this, I don't know. And the sine of pi over 2, once again, at 90 degrees, the sine is the y, it is 1. Okay, remember, x and y. Okay, or I can just go down here. I know it's hard to see, you can zoom in on your own. Sine of pi over 2 is 1. And then kind of go, okay, hey, look at this. 0 times anything is 0. Cosine times 1 is cosine. Hey, I proved it. It's like 5.1. It's true that the sine of an angle plus 90 degrees is just the cosine of the angle. And when I put in the formula, it all disappeared. So it is kind of cool where these came up with. But once again, they're just to prove things. And in reality, in real life, if we need to know an angle, we just punch it in. Okay, so that's it. You can go ahead and try them. Check out my homework online. See what you can do. Okay, and to get credit, I want you to make sure you do number 15 by hand on paper. Take a picture of it and submit. It says sine of 105 degrees. So try to figure out, what can I do? It's sine. Is there two numbers that add up to 105 or two numbers that subtract the 105? You have to pick something off your list. Find two things that either add to 105 or subtract to 105. Not sure. And depending which one you use, whether you use add or subtract, follow the pattern. Write out your pieces. Get like your fractions. Add up your fractions and get your answer and take a picture. If you're incapable of taking a picture of the homework and submitting, like I can't do that, then type in your answer if you can't photo. Okay, remember your answer won't be in decimals, it will be in fractions. Do the best you can of typing a like fraction or radical into the computer. Have fun.